Hello dear learners. Now we will discuss in this lecture another problem that is called 0-1 knapsack problem, which can be solved using dynamic programming. So the problem scenario is the same as we discussed during the fractional knapsack problem, which we solved using this greedy approach. Okay, so let us recap the problem scenario. A thief is robbing a store and he can carry a maximal weight W into his knapsack. And there are n number of items which are available in the store. And we are also given the weight of each item and the profit of each item. If the item's index is I, then its weight is Wi and its profit is Pi. And what is our motive? We should pick the items in such a way that the thief will carry only those items for which he will gain a maximum profit. Plus, the weight of those items should not exceed the capacity of the knapsack, right? So we saw that the fractional knapsack problem can be solved using the greedy approach. And 0-1 knapsack problem cannot be solved using the greedy approach, right? For 0-1 knapsack problem, we have to use the dynamic programming approach. So let us recap again the 0-1 knapsack problem. What is 0-1 in 0-1 knapsack? So 0-1 is the property which says that the thief cannot break an item into fractions. He can either pick the item or leave the item. In the fractional knapsack problem, the thief was able to break the item into fractions, which is not possible in the 0-1 knapsack problem. So here we are given an array pro from 0 to n minus 1. It means it is an array which is storing the profits of n items. Total n items are there. Okay. Similarly, there is an array weight which is storing the weights of those n items, and we are also given the maximum capacity of the knapsack, that is capital W. And the objective is to find a subset of items. We have to pick some of the items such that it maximizes the profit. And the constraint is that the sum of weights of items in the knapsack should not exceed the capacity of the knapsack, right? So another assumption here is that the profits and weights are positive numbers. So what is the simple strategy to solve this problem? The simple strategy is consider all the subsets of item, all possible subsets, right? Calculate the total weight and profit of all these subsets. So if there are 3 items, then how many subsets are there? There are, for each item, we can pick an item, we can leave an item. We can pick an item, we can leave. So for each item, we have 2 choices. Okay. So total subsets which are possible are 2 raised to power 3 with 3 items. So total 8 subsets are possible, right? So for each of these 8 subsets, we will calculate the total weight and profit. And then we will consider only those subsets whose total weight is smaller than capital W, which is the capacity of the knapsack, right? And from all these subsets which we considered in the previous step, we will pick the subset which is giving us the maximum profit, right? So how can we implement this simple solution? We can implement it using simple recursion, okay? And as I told you before, that if you want to consider all the subsets of items, then for each item there are 2 cases. The first is the item is included in the optimal subset, and the second is the item is not included in the optimal subset, right? So it means that the maximum value that can be obtained from n items is the maximum of two possibilities. What are those possibilities? The first possibility is excluding the nth item. So when you exclude an item, then suppose item number 1, item number 2 and item number 3. Okay, so this is the nth item. You can include it or you can exclude it. So if you try to exclude it, if you decide to exclude it, then what will be the maximum profit you can obtain? Now the maximum profit will be the maximum profit obtained from n minus 1 items. And the weight, maximum weight of the knapsack is capital W, right? And if you decide the other way, that is, if you decide to include the nth item, okay, then what will be the maximum profit? The maximum profit will be the profit of nth item, right? Because we are including it, so it means we are getting its profit. Okay, so we are getting its profit plus the maximum value which can be obtained from the remaining n minus 1 items, right? And now your weight, because you have picked this item, you have included the nth item, your weight will, the total capacity of the knapsack will decrease, right? So before picking this item, the capacity of the knapsack was capital W. After picking this item, now the capacity of the knapsack will decrease by W minus weight of the nth item, right? So now these are the two possibilities, by excluding the nth item or by including the nth item, right? And one important point to note here is that if the weight of the nth item, the item which you are considering, is greater than the capacity of the knapsack, then you do not need to decide whether you want to include it or exclude it. In that case, you have only one option. You have to exclude that item. Nth item cannot be included, right? So this case 1, this is the case 1, is the only possibility if the weight of the nth item is greater than the capacity of the knapsack, right? So this is how this simple solution is implemented. Okay, so let me go through this solution. So what is it saying? It is saying that capital W is the capacity of the knapsack, and this is the weight array which is giving the weight of each item, and this is the profit array which is giving you the profit of each item. And when you call this knapsack, initially there are n items in your store, right? And the best case is when n is 0. It means there is no item in the store, right? In that case, the profit will be 0, right? So we will return a 0. Or the second best case can be when capital W is 0. That is, the capacity of the knapsack is 0. In that case also you will return a 0. Okay. So this is the best case. And the second case which we will consider is this. That is, if the weight of the nth item, we are starting with the nth item, right? From nth item we will go backward till the first item. Okay, so it is saying that if the weight of the nth item is greater than the capacity of the knapsack, then also this item cannot be included in the optimal solution, right? So if weight of nth item, why n minus 1 here? Because the indices here are starting at 0. So the nth item will be stored at n minus 1 index in the array, right? So if the weight of the nth item is greater than the capacity of the knapsack, then we have to exclude this item. Then we will recursively call the knapsack. Weight is W. Weight is not changing because we have not put the nth item into the knapsack. We will pass this weight array, this profit array, and now the items to consider are n minus 1, right? Okay, so this is also done. Now the third case. This is the third case. It is saying that you have two possible choices. You can include the nth item or you can exclude the nth item, right? So it will return this. This is case 1 when your knapsack is empty or your store is empty. This is case 2 when your nth item's capacity is greater than the capacity of the knapsack. And this is case 3 when none of these case 1 and case 2 are true. So you can include the nth item in the knapsack. But you will decide whether to include it or to exclude it, right? So you will decide on the basis of the profit. Okay, if by including that item you are getting more profit, then you will include the item. If by excluding the item you are getting more profit, then you will exclude that item. So you will pick the maximum of these two cases. So let us say this is case 3A and this is case 3B. Okay, item included and item excluded. Here is item excluded. Okay, so whatever is giving you the maximum benefit, you will pick that one. Okay, so this is case 3A, that is the item is included. In that case, what will happen? You will earn the profit of that item, right? Profit n minus 1 because nth item is stored at index n minus 1. Okay, so profit of nth item is added to your total profit, and the remaining problem which is left is this: knapsack W minus weight of nth item. Why? Because you have picked that item. Now your capacity of the knapsack will decrease by the amount equal to the weight of that item. So W minus weight of nth item. Okay, you will pass the weight array, you will pass the profit array and the remaining number of items. After picking nth item, the remaining items are n minus 1. Okay, so this is the case A. And what is the case B? Case B is you are excluding the nth item. In that case, the weight of the knapsack will not decrease. It will remain as it is. You will pass the weight array, you will pass the profit array, and now you are excluding it. You are excluding the nth item. So the items which are left to be considered are n minus 1. Okay, so you will do it recursively till you get all the subsets. Okay, so now let us look at it. Let us look at the recursion tree this simple solution is giving us. Okay, so let us say that you have 3 items. Okay, so the weight of each item is 3. Okay, and you also have some profit associated with each item. So let us say the profit is 10, 20 and 30, right? And the capacity of the knapsack is 4. Okay, number of items are 3. Okay, let's change this capacity of the knapsack equal to 2. Okay, you have 3 items and their profits, and capacity of knapsack is 2. So the number of items you have to consider are 3. Okay, so initially let me write this recursive call. Knapsack weight is 2 and the number of items are 3. Okay, so I'm not writing this weight array and profit array because they are redundant. Okay, so they are implied. I'm emitting them here. Okay, so initially this is the call. Okay, so for nth item you have two choices. You can include the nth item or you can exclude the nth item. Okay, so when you include, let us say this is 1. 1 means include and 0 means exclude. If you include this item, right, then what will happen? You will earn its profit, right? And what is the problem which is left? The problem which is left is this is W and this is N, right? So weight which is left after picking this item is 1, right? Because the weight of this item is 1. Okay, and the number of items which are left are 2, right? And if you decide to exclude it, then the weight will remain as it is, 2, and the number of items will decrease because you have made a decision on the nth item. Now n minus 1 items are left to be considered. Okay, so 2 comma 2. Here again you have two choices. Now you have two items, and here also if you pick this any nth item, you can include it or exclude it. If you decide to include it, then in the knapsack the weight left will be 0, right? Because initially the weight was 2, you picked this item, the weight left is 1, again you picked, now the weight left is 0, and the number of items to be considered which are left, there is only one item which is left, right? So this, and here if we decide to exclude this, then what will happen? Weight will remain as such and the number of items left will be 1. Okay, so from here can we go further down? No. Why? Because here weight is 0. When weight is 0, this is the base case. Okay, so we are done. And at this leaf, can we go further down in the tree? Yes, because we have one item left and we have the capacity of knapsack equal to 1. Okay, so we can include the item which is left or we can exclude that item. If we include this item, then weight which is left is 0 and the items which are left are also 0. And here also the weight which is left, because you are excluding this item, weight does not change, but the number of items remaining number of items are 0, right? So this is also the base case because n is 0, w is 0, both of them are 0. And here also this is the base case because here none of the items is left. Okay, okay, and here you can see that we are solving the same problem we have solved earlier. Okay, so the same problem is being solved here also. Okay, okay, so now let's go back to this branch. Here we have capacity of knapsack equal to 2 and the number of items to be considered are also 2. Okay, so you can include this item, nth item, or exclude the item. Okay, if you include the item, then the weight left is 1 and the items to be considered which are left is also 1. And if you exclude this item, then the weight is same 2 but the items decrease by 1. Okay, so here again we can see that again the same problem which we are encountering. Okay, so we solve this problem here also, again here also we are solving this problem. So it will result in the same tree k00 and k10. Okay, and 2 1, here you can include the item which is left or you can exclude the item. If you include the item, then the weight left is 1, items left are 0, and if you exclude it, then the weight is 2 and the items are 0. Okay, so this is the structure of the recursion tree, which we get by executing this simple strategy. And here you can see that there are many problems which we are solving again and again. So it means that this simple solution has overlapping subproblems. Okay, so whenever a problem has overlapping subproblems, then we can solve it using dynamic programming approach, right? And moreover, the time complexity of that simple approach is 2 raised to power n. Why? Because we are solving solving that algorithm for each item. For each item, we are deciding whether to include that or to exclude that. Okay, so we have n items, and for all the items, we have two choices. Okay, to include or to exclude. So the total time complexity in this case is exponential, that is 2 raised to power n. So how to do better? We can do better using the dynamic programming approach. Okay. So let us take the help of an example to understand how to solve this 0-1 knapsack problem using the dynamic programming. Okay, so this is the example. Here we have the weights and the profits of 4 items. Okay, so we have n equal to 4 here. We have 4 items. We have weights and profits of each of the items. Okay, and these are the indices of the items starting at 0. And capital W, that is the capacity of the knapsack, is 7. So this is a similar kind of matrix which we saw in the coin change problem. So the approach is very much same. Okay, so weight is 7, therefore we created this horizontal axis, that is the number of columns, equal to 7 starting from 0. Okay, and here on the vertical axis, which is indexed with variable I, we have the profits. Okay, so profit of the 0th item, first item, second item, and third item, right? And now let us see the boundary cases. Boundary cases are when you have no items. I here stands for items, and J here stands for the capacity or weight of the knapsack. Okay, so when you have no items, it means I will be 0. I will be 0. Okay, so I think there should be another column, row here. There should be another row. And there is a problem here. So at 0 index, there are no items. Okay, so the profit is 0. At the first index, we have one item whose profit is 1. Then we have the next item whose profit is 4. Then we have the next item whose profit is 5. And at the end, we have another item whose profit is 7 at index 4. Okay, so these are the 4 items, 1, 2, 3, 4. And 0 means there is no item. Okay, so now it is okay. So no items means this row. When you have no items, in that case, the profit will be 0. So here we will initialize all the cells in this row equal to 0. And the second case, so no items and weight is greater than 0. you do not have any item but the weight in your knapsack is greater than 0, then it means you cannot pick any item, you cannot fill your knapsack, so the profit which you will get is 0. And the second boundary case is capacity of the knapsack is 0. Okay, so it means this column here, the capacity of the knapsack is 0, so we will also fill this column by all zeros. So these subproblems are the base or the boundary cases which we have solved. Okay, so now we will move to the next subproblem which we can solve. Okay, so the next subproblem which we can solve is this one. Okay. So here I is 1, that is you are considering the first item. The first item, its weight is 1 and its profit is also 1. Okay, and here you are taking the capacity of the knapsack equal to 1. The capacity of the knapsack is also 1. Okay, so just like the coin change problem, here also you have two choices, exclude I or include I. Okay, so if you try to exclude I, then the profit will be same as the previous profit. Okay, so I is 1 here. You decide to exclude this ith item, so the profit will be same as the profit you earned with the previous item, that is the 0th item. Okay, so this will be the profit. And if you decide to include I, then you will get its profit. Okay, so profit I minus 1. Why I minus 1? Because this first item here, it will be stored at index I minus 1 in your weight and profit array. Okay, so its profit is 1 plus, okay, so you have earned its profit. Now what is the subproblem which is left? The subproblem which is left is with the remaining number of items. Okay, so dp I minus 1, that is dp 0, and the weight which is left is j. What is j here? J is 1, the capacity of the knapsack. J is 1 minus, now you have included this ith item, right? So what is the weight of ith item? Weight of ith item is weight I minus 1, means you are looking into this array and at index 0, at index I minus 1, its weight is stored. Okay, just like at index I minus 1, its profit was stored, similarly at index I minus 1, its weight is stored. Okay, so its weight is 1. Okay, so it means after picking this item, the weight is which is left is 0. So no weight is left. It means dp 0 0. What is dp 0 0? dp 0 0 is 0. Okay, so total profit which you will earn by picking this item will be 1 plus 0, that is 1. Okay, right. Now you have considered both the cases, including this item or excluding this item. Now what is the choice which you will pick? The choice depends on the maximum benefit. Here we are trying to maximize the profit. In the coin change problem, we were trying to minimize the number of coins. Okay, so here we will take the maximum of both. So the maximum is 1. Okay, so this is solved. Similarly, we will go to the next cell, this cell. Here also we can include it or exclude it. When you exclude it, now I is 1, the item is same. Okay, so the item is ith item, I is 1 here, and j, now the capacity of the knapsack. Now you are putting it into a knapsack of capacity 2. Okay, so the capacity of the knapsack is 2. So if you exclude it, then you will copy the upper cell's contents. Okay, and if you want to include it, okay, so then it will be dp I comma 2 will be the profit of I. The profit of I is 1, and the what is left, amount which is left is now total capacity is 2, not 1, right? So now we have increased the capacity of the knapsack. Okay, so 2 minus 1 is the weight of this item. Okay, so this is the capacity of the knapsack and this is the weight of the item which you are picking. So after including this item into the knapsack, the weight which is left is 1. Okay, so what is the solution to this problem? dp 0, 1. So dp 0, 1, that is this is 0. Okay, its solution is 0. So 1 plus 0 is 1. Okay, so 0 and 1, the maximum out of them is 1, right? So now you further increase the capacity of the knapsack. Now you move here. Now the capacity of the knapsack is 3, but still you are picking only the first item. The item which you have in your knapsack is only one item which you have in this store, because we are at this location. Okay, so it means you have only one item in your store and the profit of that item is 1 and the weight of that item is also 1. So it does not matter what is the capacity of your knapsack. The profit you can earn by picking only one item is equal to the profit of that item. Okay, so it is 1 everywhere. Okay, so if you try to do it yourself, then you will find that the answer will be 1 only. Okay, and logically it means that you have only one item. Okay, and you will pick that item and the profit earned by picking that item is 1. So everywhere it will be 1. Okay, so now we move to the next row. So next row means now you have two items. Okay, you have item at index 0, you have item at index 1. Now you have two items. Okay, so now the things will change. Okay, you can include this item or exclude this item depending on the capacity of your knapsack and the profit which you are earning. So let us see what we are getting in this row. Okay, so here the weight of this item, let us look at the weight of this item. The weight of this item is 4. Okay, so here when J is here, what does it mean? It means the capacity of the knapsack is 1. So can we put an item of weight 4 into a knapsack whose capacity is 1? No. Okay, so it means you have only one choice, to exclude this item. Okay, when you exclude this item, it means you will just copy the solution from the upper cell. Similarly, when the capacity is 2, then also you cannot put this item. You have to exclude this item. When you have capacity 3, then also you cannot pick this item. You have to exclude this item. When the capacity is 4, now you have two choices. You can pick this item or you can exclude this item. Okay, so let me erase this thing. Okay, so you are here. I is 2, it means you have two items at your disposal and the capacity of the knapsack is 4. And you decide to exclude this item. When you are excluding this item, you will simply copy the solution from the upper cell. Okay, so 1, 4, the solution there is 1. And when you decide to include this item, 2, 4, you will include its profit. Profit of this item, the item at location 2 will be stored at location 1 in this array. Okay, so the profit you are earning is 4. The profit you are earning is 4 plus, now what is left in your knapsack? dp I minus 1, I is 2, so I minus 1 is 1, and in the knapsack the total capacity was 4 because we are at column 4, and after picking this item its weight is also 4. So in the knapsack what is left? In the knapsack nothing is left. Okay, so the sub problem which is left is dp1 comma 0. What is dp1 comma 0? This is 1 and this is 0. It is 0. So 4 plus 0 is 4. So out of 1 comma 4 you will pick the maximum. So it is 4. You will include this item. Okay. Now let us move to this cell, fifth cell. When you decide to exclude it, then you will just copy the contents from the upper cell, and when you decide to include it, you will include its profit. Its profit is 4, right? And the capacity of the knapsack is 5. Okay, now it's 5. And so after picking this item, it means we have a room for one weight equal to 1 still which is left. Okay, so this is the sub problem which is left. And what is the solution for dp1 comma 1? dp1 comma 1 is 1. Okay, so 4 comma 1 is 5. Okay, so the profit you can earn by picking this item is 5. So you will pick this item. Okay, so now let us move to 6. First you will decide to exclude it, and the second option is to include it. So after including this item, the capacity left is 2. So we have already solved this problem. What is the solution for capacity equal to 2? By looking at the previous item. Okay, so 1 comma 2. 1 comma 2 is 2. Okay, so 1 comma 2 is not 2, it is 1 comma 2 is 1. Okay, so 4 plus 1 is 5. So you will pick this item. Okay, now let's move to 7. Excluding this item, the profit earned is 1, and by including this item, the profit which you can earn is, again it is 1. Okay, so it will be 5 here, right? Okay, so let's move to the next row. Okay, so here it means that now you have 3 items. The item with weight 1, the item with weight 4, and the item with weight 5. Okay. Okay, so when you can see here that weight of this item is 5. So when the capacity of the knapsack is 1, you cannot include this item. So you will copy the solution from the above cell. Similarly here also, and here also. Okay, because here also the capacity of the knapsack is 4. But when the capacity of the knapsack becomes 5, then you have 2 options: to include this item or to exclude this item. When you exclude this item, then you will copy the upper solution. And when you include this item, then what will happen? You will include its profit. Its profit is 5. And then you will look at the previous solution. So dp2, and here the capacity of the knapsack is 5, and when you pick this item, its weight is also 5. Okay, so it means that 5 minus 5 is 0. So 2 comma 0 is the problem which is left. Means you will look at the previous scenario when you had only previous 2 items. You did not have this item. Okay, and capacity of the knapsack was 0. Okay, so 2 comma 0 is 0. So it means 5 plus 0, it is 5. So already it is 5. Okay. Okay, so now let us go here. Now the capacity of the knapsack is increased by 6. increased by 1, it has become 6. Okay, so when you exclude this item, then the profit you can earn is 5. When you include this item, the profit you can earn is the profit of this item plus the previous subproblem, that is dp2 with weight 6 minus 5, that is with weight 1. So 2 comma 1 is 1. This is 2 comma 1, it is 1. Okay, so the profit you can earn is 6. So out of 5 and 6, the maximum is 6. Okay, and then you move to this column, this cell, and here you can exclude this item, then the profit will be 5. You can include this item, then the profit will be the profit of this item plus the solution to the previous subproblem, that is dp2, and here 7 minus 5. The capacity of the knapsack is 2. So dp2 comma 2. What is 2 comma 2? It is 1. Okay, so it is 6. The maximum is 6. Okay, so this is also solved. Now you go to this row. It means now you have all the items. Okay, you have the previous items and the optimal solutions for those items, and now you will look at this new item, whether to include this item to the previous optimal solution or not. Okay, and the weight of this item is 7. Okay, so when the capacity of the knapsack is 1, you cannot include this item, so you will copy the upper solution. Similarly, when weight is 2, you cannot include this item. When weight is 3, you cannot include this item. When weight is 4, you cannot include this item. When weight is 5, you cannot include this item. When weight is 6, you cannot include this item. When weight is 7, you can or cannot include this item. Okay, so you have two choices. So first is excluding this item. So you will copy the solution from the upper cell, and the second is you include this item. Okay, so you will earn the profit of this item plus the solution to the previous subproblem, that is dp3 with the weight left in the knapsack 7 minus the weight of this item, that is 7. 7 minus 7. Okay, so it is 3 comma 0. Here it will be 7. So the total profit is 7 plus dp3 comma 0. So 3 comma 0 is 0. Okay, so out of 6 and 7, the maximum profit is 7. Okay, so this is the solution to this knapsack problem. The maximum benefit you can earn is 7. Okay, so let us look at the algorithm. Algorithm is quite similar to the coin change problem. You have capacity of the knapsack, you have the weight array, profit array, and the number of items. Okay, so you create this matrix dp n plus 1 w plus 1, where n is the number of items and w is the capacity of the knapsack. And then you run two loops, for loop and for I loop and j loop. Okay, so the I loop iterates over the rows, and the j loop iterates over the columns. Okay, so the base case, the first condition here is the base case. When I is 0, that is you have no item, or j is 0, that is you do not have any, your capacity of your knapsack is 0. In that case, the solution is 0. Okay, and then this was the case 1, which we discussed in a previous slide. And then this is the case 2, when you have no other choice except to exclude that item. When you have to exclude that item, when the weight of the item you are considering is greater than the capacity of the knapsack, right? In that case, you will simply copy the solution to the previous subproblem, right? And then the case 3, when you can include the item, but you will decide whether to include or not depending upon the profit which you are earning. whether you are earning maximum profit by including the item or maximum profit by excluding the item. Okay, so these are the two equations which we discussed in the previous slide. Okay, so by including the item, you will include that item's profit, and the sub problem which is left is this. Okay, that is with previous number of items and the weight which is left by including that item. Okay, and when you decide to exclude this item, then you will simply copy the solution from the previous cell. Okay, and after the completion of this for loop, then the last cell, that is the cell N capital W, it will contain the solution. Okay, so the solution will be returned by this algorithm. Okay, and now let us look at the complexity. The complexity is simple. It is equal to the number of times the I loop is running multiplied by the number of times the j loop is running. Okay, so the I loop is running equal to the number of times there are items. Okay, so there are n items, I loop will run n times, and capital W is the number of times the j loop will run. Okay, so this is the time complexity of 0 1 knapsack using the dynamic programming approach. Okay,